I am here to walk you through the process of estimating labor for a specific activity. Before you do anything, you should always read anything that seems like instructions. This one, it's the basic labor estimating workflow. That's telling you the process. And on this one, which is on the right, you can see this is your A9 labor spreadsheet homework. What I've done is I just want you to turn in the Excel spreadsheet itself. I tell you use Excel to estimate it for the 3 scenarios, assuming a system efficiency of 50 minutes out of 60 minutes. And then the lookup tables for labor rates, productivity rates, and cycle times. And if you look at lookup table here, it says first you would derive the historical productivity factor for each crew composition and site conditions. Then you figure the historical productivity rate of the task. In other words, how much can be performed generally in an hour. Then you derive the historical system efficiency. Well, I told you that it's 50 out of 60. Then you compute the labor hours for the task, which doesn't have any of these things. It's just the productivity rate. Then you adjust the labor hours for the productivity factor. Then you figure out, okay, well, what is that divided by the number of crew members? Then you figure out, okay, well, how much does that crew cost? And how many days will it take the crew? And if you look, here's the historical production factors. You can see this is production factors based on labor characteristics, work conditions, and non-productive activities. There's quite a bit of non-productivity that goes into working, believe it or not. And all of these amounts are researched. They're based on that website, which you are welcome to look at. I encourage you to do that. Historical cycle times. Remember, historical just means we've already got the data and now we're going to use it on other similar projects. So pouring ready mixed concrete, placing reinforcement in concrete, slip forming. And then here's labor rates. Skilled is high skill level, novice is average skill level, and a helper has little skill. So these are all the different things, and I looked at 4 different websites to gather this information. So you've got all of this data. Let's look at our actual thing here. You can see it actually, again, gives you that same basic labor estimating flow. But here I even say how to calculate. All of these productivity factors of crew, skill level, and condition factors, you saw they're all in here. I want to know how many days. And that's because when you're doing project management, you have to know how many days something will take. And so this is information that you're going to need to input into Microsoft Project eventually. So let's look at an example. So you can see I've rearranged how this is. If you saw it in a previous version, the task comes first and there's job total and unit. So let's look at one that's not finished. You can see those are blanks. You'll need to put those in. And then the production factors go here. The crew size, I've already given you. All I did was add it up. I figured you could do that. The crew hours, the crew hour cost, rather, is, as you can see here, just adding up. You can see one skilled person is $19.90 per hour. A novice would get $16.27 per hour. Well, where did I get that? I came over here and looked at labor pay rates, excavation, and there they are. And look, a helper is actually not allowed to work on excavation because it's too dangerous. So that's where I got that. I have the production factor for the crew. The crew production factor is the average of all of these. So let's look here on the lookup table. Production factors, it's right there on its own tab. So worker skill, and the instructions, it said high skill means skilled, average skill means novice, low skill is a helper. And then I did a little bit of explanation. Some people had been asking this. Why are production factors less than 1 meaning slower work. And it's because they're actually at the bottom of a fraction when you do the math. So let's go back to the example. Here's this crew production factor. I'm doing an average of high skill and 2 average skills. So that is, high skill is 1.1, average skill is 0.95. And when you average those together, lo and behold, you get 1. Site size is average. Anytime you see the word average, it's going to be a 1. I didn't even look at it. So now let's look at, job complexity. Simple. And I look it up, and I put it in my spreadsheet. Climate. Well, it's late winter, and that's the coldest time of the year, so it's cold, so 0.85. Indirect labor. So indirect labor is the labor required to maintain the project site conditions. So if it's particularly rainy or windy, you're going to need to do a lot of covering up in the middle of the day, certainly overnight, and that sort of thing, just to prevent erosion and damage to your materials. So it's labor, and it's got to be paid for, but it's indirect labor. It's not labor that's actually accomplishing the project. So that's why it's called indirect labor. And you can see it's late winter. So if you look here, this, and you can see in yours, it says divided by 0 error. That's because these are all zeros up here. But on the example, you can see since there's data in this production factor column, then it actually does have a value. Now it's a productivity factor, so it does not have a unit. And it says right next to it, average of all crew and condition factors on the lookup table. I'm just giving you a lot of support. I know that this seems complex. It's really just a lot of arithmetic. You can do this. So the productivity rate of the task. Well, what was my task? Excavating a roadbed. So now I look at cycle times. Even though it's a linear project, I had to name the tab something. So look here, roadbed excavation, 124 feet per hour. So I put the 124 in the value. I put the feet per hour in unit. Notice all it says here is per hour. You have to put what that is. And if you look way up at the tippy top, you've got a job total. Now, because this is linear, in my description of the task, I'm excavating 3,120 feet. And so my job total is 3,120 feet. When we go to something like installing windows, it's going to be the number of windows. So keep that in mind. You've got to be aware of what your units are. So then we go ahead and put this in. I'm going to go ahead and make these yellow for you so you know that you have to input them. And then you can see that really all the rest of this is calculated for you. And I went ahead and put those in because I know that you're not necessarily going to be as savvy as me at Excel. Trying to make this as automated as I can for you. And so you still understand the concept without getting lost in all of the programming. Although you really should learn how to program in Excel. Formulas at the very least. So then the labor hours required for the task, as if only one worker. So the labor hours, so we know that it's 25.16 hours to do this job, divided by the productivity factor, which we calculated here, times the system efficiency. And so you can see up in the formula bar, it's just times 50 divided by 60, because it's the same for all of the scenarios. And then we take that adjusted labor hour and divide it among the crew. And so you can see this takes that step 4 divided by crew size. And then remember, we figured out how much 1 hour costs to operate that crew. It's our minimum cost, but it doesn't take 1 hour, it takes 10.52 hours to excavate this short stretch of road. And so that would cost us the total hour cost for the crew times the crew adjusted labor hour, so $551.93. Okay, well, it's 10.52 hours, but Microsoft Project works in units of days. So we went ahead and divided it by 8 and got the number of days. So I hope that this demonstration helped you, and having the example there will help you. If you have any questions, please contact your instructor. Thank you very much.